In this video, we're going to introduce the concept of suffix-changing functional groups when naming organic compounds. Our first two suffix-changing functional groups are alkenes, or double bonds, which have the suffix ene, or ene, and alkynes, triple bonds, which have the suffix yne, or yne. Recall that a 5-carbon alkane would be named pentane, so a 5-carbon alkene would be named pentene, and a 5-carboned alkyne would be named pentyne. With alkenes and alkynes, we do have to add a number indicating where the alkene or alkyne is in the chain. You can see that you can put it before the ene or the yne. It's also acceptable to put the 1 in front of the entire root name and say 1 pentene or 1 pentyne. Suffix-changing functional groups have special priorities, which we'll talk about in the next couple slides. In Interchapter A, we walked through how to name organic molecules, and most of the steps that we're going to use for naming alkenes and alkynes will be the same. However, there are a couple of steps that will change, and I've outlined those steps in bold. For example, step 1, determine the suffix. Of course, the suffix is going to be different if you have an alkene or an alkyne, so that part's going to change. Also, step 2 is going to change, because now our parent chain must contain the suffix-changing functional group. That means that our parent chain isn't necessarily the longest chain in our molecule, it's simply the longest chain that contains the suffix-changing functional group. In the case of an alkene or an alkyne, which contains 2 carbons, that means that both of the carbons have to be in the parent chain. Also, step 6 is going to change for us a little bit. Typically, we number so that the first substituent has the lowest possible number. Now this part in parentheses that says or most important becomes what we need to focus on. So we have to number the parent chain so that the suffix-changing functional group has the lowest possible number. Now we're going to ignore all the other substituents and give the suffix-changing functional group the lowest number first. We're going to look at more examples of these on the next couple of slides. As I mentioned, the parent chain must contain the suffix-changing functional group. In our first example here, notice that both carbons of the alkene have to be part of the parent chain. So the parent chain can't be 1, 2, 3, 4, 5, 6. It has to be 1, 2, 3, 4, 5. Here's another example. We have a 4-carbon chain here. It's not the longest chain, but it is the one that has the suffix-changing functional group. So even though this is longer, we're going to make the parent chain the one that has the suffix-changing functional group. The same thing is true for alkynes. Again, the parent chain must contain both carbons of the alkyne. Once we've determined the parent chain, we have to number the parent chain to give the suffix-changing functional group the lowest number. In the case of this first example here, you can see the parent chain here in pink. If we didn't have the alkene, we'd put the 1 here because we have a substituent at that position. However, the alkene is a suffix-changing functional group and takes priority. So we're going to number from the other side to give the alkene a number 2. If we start from the right, 1, 2, 3, the alkene will get a higher number. The only time we take the substituents into account is when we're going to give the alkene the same number from either side. So in this case, 1, 2, 3 versus 1, 2, 3, either way we number, the alkene will be getting the lowest possible number. So now we look at the methyl group and we give it the lowest possible number because we've already given the alkene the lowest number possible. The same thing is going to happen in rings. In this example on the right, we want to give the alkene the lowest possible number. That means that both carbons of the alkene have to have the 1 and the 2. In this case, we put the 1 here versus here because we have the nitro group here. So we can use that substituent there to decide where the 1 should be. In the next couple of videos, we're going to go through several examples of naming alkenes and alkynes using what we've learned here.